In general, chemical reactions are unbalanced in terms of their molar relationships. We almost always will have the case where one of our reactants is going to be stoichiometrically lacking compared to the other. In other words, we'll run out of one before we will the other, and thus it will limit the amount of our product that we are looking for. So let's take a look at how we can determine what our true theoretical product would be when we have two reactants and really don't know which one we're short on. So in this case, we have 6.5 grams of solid magnesium that we'll place in an aqueous solution that has 14.9 grams of hydrochloric acid. If that's the case, how much hydrogen gas in volume of liters at standard conditions could we get as a result? So what we need to do is run stoichiometry for both reactants, because we don't know which one we stoichiometrically are short on. Essentially, once we've run the two equations, whichever one of these produces the least amount of product, well, that's our limiting reagent. And the amount that is produced by that limiting reagent is our actual theoretical yield. That means the other one is in excess and will actually have some of it left over, assuming that the reaction goes to the level of completion that we predict, which generally doesn't happen. But we always need a baseline of possibility. That's our theoretical yield. So what I want you to do right now is try that three-step process that we've been going over in our previous videos to run these two equations to see which one of these truly is limiting and thus is the one that produces the theoretical yield. If you're still shaky about that method that I've been using, go back and review those videos and before you try to tackle this. Once you feel confident, let's give it a try and see how you did. I'll pause the video at this time. So, we've set up two equations to determine what the true possible yield of this chemical reaction is when we have the reactants hydrochloric acid and magnesium in these mass amounts. The value that we're looking for as a target is hydrogen gas in volume liters at standard conditions. And we've been learning that the molar volume of a gas, no matter what the gas is, as long as it's under standard temperature, which is an atmosphere, and standard pressure, which is an atmosphere, and standard temperature, which is 0 degrees Celsius, will occupy roughly 22.4 liters. So this becomes our molar conversion for our unknown value for hydrogen. In both cases, since we had gram amounts as our known values, we needed to convert them to moles by dividing them by their molar masses. Then we have the unknown over known, which is the heart of all stoichiometry problems, drawn from our balanced equation here. 1 mole of hydrogen, our unknown, over 2 moles of our known hydrochloric acid, 1 mole of hydrogen over 1 mole of magnesium. This solves for the unknown in moles. We want to convert them into liters by multiplying by the molar volume of that gas conversion value, and we find that the theoretical yield for this reaction is 4.57 liters. We know this to be the case because this is the smaller of the two. It basically tells us that we're going to run out of hydrochloric acid. This is our limiting reagent. And we'll actually have some unreacted magnesium left over. That's our excess. In our next video, we'll try to figure out if we had truly reached this theoretical value, how much of the magnesium did we actually use and how much would be left over?